Okay, some examples of derivatives using this more involved, more useful rule for derivatives of log functions. So here's the rule. The derivative with respect to x of natural log of u is the derivative of u with respect to x over u. Okay, so you're going to probably use this rule anytime you're asked to take the derivative with respect to x, let's say, of natural log of anything else. Okay, not just x, but some more complicated function of x. And that's what u represents. So actually this is a pretty easy rule to use once you get the hang of it. You know, if you look at this derivative we're asked to compute, it's really just exactly this rule. You know, the thing inside here, the thing that's acting like u, is x squared plus 1. And the rule says just take the derivative of the thing inside of the log, and divide it by the original thing that was inside the logarithm. So, you know, the derivative of x squared plus 1 is just 2x, and I divide that by u, which is x squared plus 1. Okay, that can't be simplified. That's it. That's the final answer. Okay, and in fact that's a pretty easy rule to use, but you know, where the problems get tougher is when we have to combine it with more and more of our old rules. So if you look at this one, we're going to have to do exactly that. If you ignored the x squared, I mean, you could just use the old rule, right? It's natural log of some function. But you see, we can't quite go yet to that new rule because we have a product here. We've got x squared times natural log of 3x plus 1. So first we're going to have to use the product rule. Remember, the product rule tells us how to take the derivative of a product of two functions. So one of the great tasks ahead of you in these sections, just like we've had in the past, is you really have to look at the thing inside of the derivative that you're asked to compute the derivative of and break it down into pieces. So fundamentally what we have here is a product. So I start with the product rule. And the product rule says, I always like to start a product rule problem writing my 4 blanks because I have to compute 4 things here. It says take the derivative of the first function times the second plus the first function times the derivative of the second. Okay, so if this is f and this is g, it goes f prime times g plus f times g prime, or g prime times f. But first I have the derivative of the first function, which is 2x. Okay, derivative of x squared is just 2x. Okay, then I multiply that by the original second function, natural log of 3x plus 1. Sorry for the small writing there. Okay, and now I have to add it to, and again the book I think says g prime times f, or f times g prime, either way. So it's the derivative of the second function, okay, and for that I need the new rule. Now what we have here is, for the log, it's natural log of u. Okay, the rule that we just had says take the derivative of u, which is just 3, right? The derivative of 3x plus 1 is 3, and divide it by u. Okay, so that's the derivative of the natural log function. And finally I have to multiply it by the original f function. So all I've done here really is fill out the product rule. F prime times g plus g prime times f. I think that's the way the book writes it. Okay, so really the new rule came about right here, and that's really it. So for the final answer, we'll just say 2x times natural log of 3x plus 1, okay, plus, well, I can write this as a single fraction. Alright, I can write that as x squared over 1, so I get 3x squared over 3x plus 1. Okay, and that's certainly okay for a final answer. We've got a fraction and something that isn't a fraction. There's no reason to add those together. Okay, so a little bit tougher, and that's what you'll see when you have to combine rules. Things get a little bit more complicated. Moving on to this last one, I'm going to show you a tip or two here, but when you look at this, it sounds like, again, kind of one of the basic examples, because what we have here is natural log of some function. Okay, so we could go right away into calling this u, right? We have natural log of u. This would be u. And then we would just say that's, well, it's du dx over u, right? That's what the rule says. And you can do that, and that's perfectly fine. But one thing I'll encourage you to do is that, remember, there are some rules of logarithms, and rules we can use to simplify expressions with logarithms. And I think in a problem like this, you might find it more beneficial to simplify the function first before you take its derivative. And let me show you what I mean here. So now I'm referring to these rules we had in, I believe, section 4.4 about how you can rewrite logarithms. Okay, so I'm not going to take a derivative just yet. Okay, what I'm going to do is rewrite this logarithm. One of the rules we had said if you have a logarithm of a product of two things, you can write that as log of the first term in the product plus log of the second term in the product. Okay, now why am I doing that? Well, I'm doing that because if I were to use the new rule right away, I would have to compute the derivative of this big mess inside. And you can probably look at that and think the same thing that I'm thinking, that, that's kind of messy. We're going to have to use the product rule and the generalized power rule and all of that stuff. So I want to avoid that. So it's perfectly okay if I have a rule that allows me to rewrite this, to rewrite the term inside the derivative first before I do any derivatives. Okay, and actually I can do one other rule of logarithms over here. You might think about it and see if you see what I can do. But what I have here is natural log, and I'm going to go ahead and just erase it here to save some writing, of the square root of x plus 3. Okay, well that's actually x plus 3 to the 1/2, isn't it? Okay, so here's what I really have. I've got the derivative of natural log of x, okay, and then I've got a rule here as well. Remember we had that rule for powers of logarithms. If you take natural log of something to a power, you can write the power out front as a factor, and then take natural log of the base that was inside. Okay, so all I've done in going from here to here, I haven't done any derivatives. I haven't done a single derivative. All I've done is I've rewritten the log. Okay, and again, I've done that because I think that that's going to make the problem a little bit easier to finish. Okay, so why does that help? Well, now I can just take the derivative of the first term, right, using the sum and difference rule. So I'll take the derivative of natural log of x, and then I'll take the derivative of the second term. Okay, right, the 1/2 natural log of x plus 3. But you know what? I can go ahead and factor that 1/2 out of this term. Okay, get something like this. Okay, so look at what we got here. Derivative of natural log of x. Well, that was the first rule we learned in this section, just 1 over x. Okay, plus 1/2. Okay, and then here I use the new rule, but it's much easier to use. Right, I have to take the derivative of natural log of u, but the derivative of u, this thing, is just 1. So that's 1 over u, which is x plus 3. So at the very end I get 1 over x plus, I could write this as 1 over 2 times x plus 3 if I want to combine that into a fraction. And that's the correct answer. If you wanted to, you could get a common denominator and add these together, to get a single fraction, but this is okay. There's nothing wrong with that. Anyway, I put this in here. It's maybe something that if you saw the same example in the book, they wouldn't use these rules of logarithms first, but I think it makes it a lot easier. We don't have to use any complicated rules for derivatives if we can just simplify the logarithm first. So the derivative of that logarithmic function is just 1 over x plus 1 over 2 times the quantity x plus 3.